بداية أود التعريف بالمحاضر ضيفنا الأستاذ الدكتور سعد مريان. الدكتور سعد نائب رئيس منظمة جنى خريجي جامعات أمريكا الشمالية، وهو أستاذ في القسم الهندسة المدنية تخصص مصادر المياه، ومنسق برامج الدراسات العليا في قسم الهندسة المدنية في جامعة ولاية كاليفورنيا الولايات المتحدة الأمريكية. حصل على البكالوريوس في الهندسة المدنية من جامعة العلوم والتكنولوجيا عام 1993، والماجستير في الهندسة المدنية من جامعة ميزوري كولومبيا عام 1996، والدكتوراه من جامعة وين ستيت ميشيغان عام 2001. يركز في أبحاثه على تحليل أنظمة الموارد المائية وتصميمها وتأثيرات المناخ والتكيف معها. عمل الدكتور مريان مستشاراً للمصادر المائية لوزيرة الغذاء والزراعة في ولاية كاليفورنيا، وعمل أيضاً في القطاعين العام والخاص في الولاية. الدكتور مريان حاصل على رخصة تقييم مخاطر المشاريع المائية ذات الحجم المتوسط والصغير. الدكتور مريان لديه العديد من الأبحاث المدعومة والمنشورة في العديد من المجلات المحكمة. يسعدنا استضافتك أستاذي، وأهلا وسهلا بالحضور جميعا، وتفضل بإمكانك تباشر. أو دكتور آسف،
خليني أحكي أنا بس باسم الشعبة. رحب بكم، أنا مهندس عيتر نائب رئيس الشعبة المدنية. نرحب بالأستاذ الدكتور سعد مريان وبكم جميعا، ونشكر رئيس اللجنة العلمية وزملائنا اللي قاموا بهذا النشاط، الدكتور أنيس الشطناوي صديقنا العزيز وزميلنا. موضوع الندوة طبعا موضوع مهم جدا، وهو يتماشى مع سياسة الشعبة في الدورة السابقة وفي الدورة الحالية، والتي تركز على القضايا العملية، وأن تكون الهندسة أساسا في خدمة قضايا الوطن ومشاكلنا التقنية بعيدا عن النظريات. موضوع المياه طبعا يعني لا حاجة لنا نتكلم كثيرا عن الموضوع، هذا موضوع أساسي في الأردن، خصوصا أنه إحنا بلدنا يعتبر من أفقر الدول في حصة الفرد من المياه، ونلاحظ حتى التغير المناخي مؤثر علينا من بين كل العالم في آخر فترة، يعني الهطولات المتقطعة والشديدة. شفتوا اللي صار في آخر مرة في زرقاء معين. أنا الحقيقة لفت نظري موضوع يعني إضافة إلى المأساة الكبرى اللي حس فيها كل بيت أردني بفقدان شهدائنا وأبنائنا، هو كمية المياه الضخمة التي تذهب هدرا. يعني هاي المي حتى لو انها سيل جارف وكذا، بس في مشكلة عندنا بالاستفادة من مصادر المياه. يعني عم ندور دوار على الفيضانات عشان يصير عندنا شوية ريزيرف، فبتتفاجأ انه في سد انتلى من اول شتوة، وفي مياه بتنزل كلها بتروح للبحر الميت بدون استفادة. انا مرة بتذكر في الدورة السابقة للشعب المدنية كان زميلنا المهندس مالك الرواشدة كان امين عام سلطة المياه، وهو خبير ايضا في هذا الموضوع. سألته شو حجم الاستفادة من الهطول المطري، لما بعطونا بيقولوا نزل علينا 1.5 مليار متر مكعب مثلا، فقال لي أكثر من 92% بيروح إما بيروح تبخر أو بيروح جريان غير مستفاد منه. لا أدري كم هاي النسبة دقيقة، خصوصا بوجود زميلنا العزيز نسيت أرحب فيه كمان دكتور رضوان وشاح، خبير أساسي ومهم في موضوع الهيدرولوجي والمياه. يعني هناك قضايا عديدة في الموضوع، نرجو أن تكون محاضرة الدكتور سعد مفيدة لنستفيد جميعا منها ومن التجربة، كيف تم حل بعض مشاكل المياه أو مصادر والتزويد في كاليفورنيا. ونأمل أن تستمر اللجنة العلمية برئاسة الدكتور أنيس وزملائه في العمل على القضايا العملية التي تمس مشاكلنا. أهلا وسهلا بكم، وتفضل دكتور.
السلام عليكم، مساء الخير للجميع. بدي أول شيء معلش صوتي عالي
بس دي حداك عندك.
أول شيء بدي أقول لكم مساء الخير. أنا سعيد جدا وجودي بين زملائي بدي أشكر صديقي وزميلي الدكتور أنيس الشطناوي على الدعوة الكريمة اللي وجهها إلي، وعلى يعني موضوع مهم كان هو إنه حب إنه أحكي فيه. فبشكركم وبشكر الدكتور وشاح زميلنا العزيز وأخونا الكبير وكل أعضاء اللجنة هون، وأشكركم على حضوركم أولا وآخرا. يعني الساعة 5:30 مساء مروحين من شغل وتعبانين، فيعني شكرا على حضوركم. تفضل. خلصنا؟ أول شيء سامعيني؟ بدي أحكي اليوم عن موضوع California Water Resources. هو California Water System is a very complicated system, and it's one of the most complicated in the world actually. It has so many moving parts that require attention. So first I'm going to be talking about California Water Resources first, then about the concerns in the water resources system, and then offer some parallels between California water system and what Jordan's system compares to California. And then offer some lessons learned, solutions, and so forth in that regard. Okay, outline of my presentation. راح يكون introduction. It's going to be a general introduction about waters of the world, waters in California. And then I'm going to offer some explanation about water systems and the definitions of some of the concepts and terms related to water resources. And then I'm going to talk about California water system. First, I'm going to talk about the supply, then the demand, and then offer what are the issues of concern in California. Like in Jordan, there are issues of concern in California as it's in Jordan related to the water resources system. And then show some comparisons between the issues that we face in Jordan, recent issues, old issues, consistent issues in Jordan, and then the ones in California. And then eventually I'm going to be talking about some of the issues and the discussions that we addressed in California to address those issues. My introduction. First, I want to give you a perspective about California. How many of you visited California or know anything about California? 1, 2, 3, 4, 5, 6, 7, 8. That's a good number. California population is about 40 million, and Jordan's population is about 10 million. So it's about 4 times the population of Jordan. The size of California is 423,971 square kilometers, while Jordan area is 90,000 square kilometers. We're talking about a scale of 4 to 4.5 size-wise. The importance of California to the United States is that California provides food security for the entire country, which is the United States, because California provides 50% of the food, fruits, vegetables, and nuts for the United States. You're talking about 165 million of the United States population uses California products as a way to sustain themselves. So it's not only a matter of water resources, it's a matter of food security for the United States. California provides 50% of the United States food. And California is the 5th largest economy in the world. So if you combine some of the European countries' economy, California's economy will be larger than those European countries combined. So, water resources. It's not a new science. It's not a new discipline. Water resources have been evolving for centuries, for 10,000s of years. Why? Why is water resources still evolving? It's not a constant science, it's a dynamic science. Why it's moving, why it's changing? Any ideas? Related to people, right? And when we start learning how to move water, when we start learning how to manage water, we evolved as humanity as well. So as we evolve, we made things better for us, we made things easier for us, we made things available for us. So basically, water resources has been evolving for centuries. So it's not a new thing. So we're not inventing the wheel, basically, in water resources. So what civilizations contributed to the evolution of water resources? I could come up with maybe 300, 400 civilizations that contributed to the evolution of water resources. But one of them is, we're coming to that. That's one of my favorite. This one, نباتينز، الأنباط. أنباط شو تعلمنا منهم؟ Terraces, water system, networks, hydraulics. That's what we learned from the Anbat, correct? Flood control, flood mitigation. And the Egyptians, what did we learn from the Egyptians? Irrigation system, irrigation networks, irrigation canals. So we did not jump from living next to a river or a creek to living in mansions with water available to us 24 hours a day. Also, a major civilization, the Romans. The Romans provided us with one of the greatest water-related infrastructure. Can you think of what is that infrastructure? أنا عارف إنك عارف. Sewage system. Was that available to everybody? No, only the elite, the top of the civilization. What else? How about aqueducts? Open channels. We learned how to move water to vast distances from the Romans. They elevated their hydraulic channels, which is aqueducts, and now we are using it in Jordan, we're using it in California, we're using it worldwide. Do you know that one of the aqueducts that the Roman built, length was 300 miles, and the error in the slope was less than 1%? That was how many centuries ago? I'm going to leave it to you to figure out that. Do I need to point it? Okay, that's good. So in this case, how do I define a water resources system? To you, if I ask you, what is a water resources system? What should be your answer? When I said water resources system, what does that mean? The first thing should come to your mind. One, there should be water, right? We should have water. Then, what else? Having water does not make a system. It makes a resource, right? So in this case, we need a network to move that water, to distribute that water, to manage that water. So we need a system. So it's finding water, distributing water from places where it's available to places where it's needed. Places where it's available هون بتكون dams, reservoirs, groundwater, for example, to places where it's needed, your apartment, my house, your farm, and your business. So that's where the places, that's what the system is. Start with a resource, then a delivery system, then a demand or a need for that water. Now, sources of water. Where do we get water? From the store? Bottled water? Is that a resource? No. Rainwater, that's surface water, correct? In Jordan. Good. Yes, which is groundwater. So the supply comes from two major resources. One is the surface water that includes rainfall, precipitation, snowmelt, all of that. And then groundwater, we have to dig deep to get that water from the groundwater basin, correct? Seawater? Seawater is a resource. Yes, it's a resource, but it's not an immediate resource for us. We have to process it further. Yes. And then, no, I'm talking about in general. That's an introduction. It's not specific to Jordan. It's a, which is, that's surface water. Whether it's recycled, whether it's desalination, whether it's a surface water obtained from a surface source, correct? Then, conjunctive use, or both surface and groundwater, that's another resource. Categories: supply, which is rainfall, lakes, reservoirs, groundwater, etc. Demands. What kind of demands we have here in Jordan? Let's go back to you. What kind of demand we have? Domestic use. Define domestic use. Domestic use? Okay. Okay. What else? That's called urban, correct? Urban use. What else? Agriculture. Anything else? Industrial. Industrial goes under urban sometimes, in some places. Yes. How about environmental? Is fish, wildlife? I know not river hone ولا fish, but environmental requirement improves water quality, and it's one of the things that we need to maintain or keep within the environment. Otherwise, we're gonna degrade our environment. Ecosystem. Now, in the world, we have a lot of water. We have big oceans, right? Vast oceans. Why don't we use that water? Why don't we use that water in the ocean? Ocean. 97% of the global water in oceans. Oceans, groundwater, and lakes. Only we have 2.5% of the global water, fresh water, available to us to drink without further treatment and additional processing. In this case, the fresh water comes in from groundwater 29%, glaciers and permanent covers about 69%, and others is about 1%, other resources, like recycling and other resources we're talking about. In this case, why do I have groundwater here, and why do I have groundwater there? Fresh and not available. Brackish water. This one is fresh, but this one is not ready to use. It could be high salinity, it could be contamination, it could be heavy metals, it could be very difficult to reach. Requires a lot of financial investment to get to the water table. Now, before I go into California water system and all the issues related to that, I want you to remember a few things. One, the nature of government in the United States. We have the federal government, and we have the state government, then we have the county government, and we have the city government. All these layers of governance are responsible for the water resources in California. So if one level decided something, the other levels has to collaborate, coordinate, and work with each other to come up with a system. So these are the four levels of governance. In California, not in the United States, in California, there are 34 storage facilities, reservoirs, and lakes. I'll show the size and the location of those reservoirs as a way of supply. 20 pumping stations or plants, 5 hydroelectric power plants. So the state requires 5 hydroelectric plants. Why it's important to have hydroelectric? Provides sustainable power, not oil or gas or not sustainable power. So it provides energy from sustainable resources like water, moving water from high places to turn turbines to generate power. In this case, 5, and those are not sufficient to operate California water system. Do you know that one of these pumping stations in California requires 10 billion kilowatt hour, not million, billion, 10 billion kilowatt hour to operate, which means it's a lot of electricity. California has to buy electricity to operate this system from outside sources, from other neighboring states. But it generates about 50% of its electrical power from hydroelectric power, from sustainable resources. The system, do you remember when we defined a water resources system? We said we need a water resource, we need an infrastructure, we need a demand. So the water resources, they are used in those places, and the delivery system is this: 700 miles of infrastructure, aqueducts, pipe, open channel, pumping stations, and so forth. So in this case, this aqueduct or this delivery system requires 10 billion kilowatt hour per year to operate, and provides water. The most important thing is that it provides water to 25 million Californians. What was the population of California? 40 million. So that's half of California relies on this one project, which is the State Water Project. The operational cost of this project is $600 million per year, one. But in this case, does that justify the cost of operation? Is it justifiable, you think? Why is justifiable or why not is not justifiable? Think. Half of the state relies on that one project. Keep in mind, 165 million Americans rely on California products, agricultural products. So that's an issue for the country as well as an issue for the state of California. Let's look at the supply. Do you remember my outline? Was first, introduction, supply, demand, issues of concern, correct? And then finally was parallels, and at the end I had some lessons learned and solutions. So now we're going to talk about the supply. Thinking about the size of California, which is about 4.5 times, 5 times the size of Jordan. What do you think the water need is there? How much water do we need? Do you think? About 40 million. How many of you are civil engineers? Raise your hand, civil engineers. Can you do this calculation quickly? This side are not supposed to answer any of the questions. Yeah? 2 billion? In Jordan, 2 billion? Definitely. But I'm asking if you want to calculate that number. What do you think? 120 liters per day. Is it liter or gallon? Gallon per day per capita, multiplied by 40 million, and you do the math, right? Okay. I think I'm moving in the wrong direction. Now, in Jordan, what is the main source of supply? Groundwater. Do we have surface water? Do we have rainfall? What is the average rainfall in Jordan? 10 centimeters. That's average countrywide? Which is 20 centimeters? Some في flood هذا بصير. هذا بيسبب floods 200 millimeters. Countrywide, 90 millimeter.
If you divide 8.4 million by the area of Jordan, which is 90,000 square kilometers, you get up a result of about 90 millimeter per year.
All right. Right. Let's look at the rainfall in California, and then you can look at the magnitude in Jordan, and you can look at the magnitude in California. You're familiar with the map of California, correct? You've seen this map before? If you haven't seen it, have you seen it, all of you? Okay. Where is Los Angeles on this map? هون؟ طيب. وين سان دييغو؟ تحت؟ هون؟ هون؟ أوكي. صح. طيب وين سان فرانسيسكو؟ هون؟ هون؟ هاي سان فرانسيسكو بالضبط. وين ساكرامنتو؟ هيك؟ هيك؟ هون؟ هاي ساكرامنتو right there. Sacramento right there. طيب شو هذا؟ What is this? San Joaquin Valley right there. That's the valley. You're off a little bit. This is the Nevada Sierra Mountains. California, from the east, we have mountains. From the west, we have the Pacific Ocean, correct? فمحاطة بين mountains. What did I do? Mountains and ocean, and it's flat in between. The average elevation from sea level in this zone is about 30 feet, which is 10 meters ارتفاع عن سطح البحر. Average. It could be lower, it could be higher. Now, since we know a little thing about California, geography and cities and so forth, what is this pretty colors? What are these? That's precipitation. That's rainfall. Let's see, look at this map. The key on the side of the map goes from 200 inches to less than 5 inches. What was the average in Jordan? 90 millimeters. 6 inches. That's the lowest in California. That is the lowest in California, 5 inches. That happens where? What is this area called? No. They were still California. بيجيبوها بالأفلام وبحطوها. Death Valley. That's the Death Valley. That's why they call it the Death Valley. It's red. If you look at less than 5 inches to 200 inches or 120 inches, as a water manager, as an engineer, is it easy for you to plan and manage a system like this with that diversity and extreme change of rainfall? It's very difficult because you cannot predict the future. With hydrology, what we try to do, we use current data to predict the future. So we can allow for a design of culvert, a design of a waterway, so we don't have flooding and loss of life and loss of property. In this case, it's a nightmare for a water resources engineer to be able to manage a system like this. So that's one thing. It's very difficult to manage. It's extreme. It goes from 5 inches to 200 inches. How in the world am I going to design for something like this? Now, precipitation happened in California from November to March. But during that period, we have snow. In this case, the snow occurs where? Where? Do you remember this part? On the east side of the state, which is the Nevada Sierra Mountains. That's where the majority of the snow accumulates. Okay? We'll talk about more about the snow accumulation. So how is that a supply, this snow accumulation? How is it a supply? What happens to the snow in the winter? Does it melt? It does not. It basically accumulates on the Nevada Sierra Mountains with time. When the spring runoff comes in, that water melts and that water changes to a fresh supply of surface water. And to know how much water we're going to get from that snow, the state creates something we call snow surveys. They survey certain paths along the Nevada Sierra Mountains, and they know what is the depth of that snow, And from the depth of that snow, they convert it to something we call snow water equivalent, which means if I took that snow and I melted, how many inches of rainfall I will get. So they do that 6 times through each year, which is basically the season. They start from January to June, predetermined places, locations, and they do that for the past 100 years. They have been doing this. Now, that was basically a map, which doesn't tell me much as an engineer if I want to design, analyze, predict, use, and computer models. So I need actual data, right? This is the rainfall in California from the 1900 all the way to 2000. Average statewide every year. So they look at that and they average for the entire state for 1 year, and then they do it since 1900 all the way to 2000. What does this figure tell you? What do you see? It's uniform or non-uniform? Variable, extremely variable. Not only variable, it's extremely variable. Look at the rainfall. Low, high, high, high. So in this case, if you want to design for the high, it's going to cost you an arm and a leg. It's going to be very expensive. If you design for the low parts here, what's going to happen? Engineers. Floods, loss of life, damage of property, all of that. So we need to find a better way for that design of rainfall. So we decided to take the average statewide, not only the average for a year, the entire 100-year record of rainfall. We want to take it and average it, which is this black line. This black line does not capture everything. It captures a mathematical average, does not capture the variation from one region to another. In this case, we decided to take another average. We took an average that is 10-year average, running average. So we accumulate every 10 years, we take an average, we move to the next 10 years, take an average, and that average is this line if it's worse than the original data. That was a bigger problem. Now, the most important thing I want you to look at this. You see this line? That's what defines where the water is and where the shortages are. That line. This is the Sierra Mountains, right? And here we have mountains as well, but the most of the snow accumulation is along this path. Read the blue line and red line and tell me what do you think? What do you see or what do you understand from those figures?
The river crossed the line in one point.
This river is called the Sacramento River, which is that's a major river in California, one of the biggest rivers in California. Has tributaries, has arms. Those arms, the Feather River, the Bear River, and the Folsom or the American River. Those are the tributary to that river. But that river, the Sacramento River, flow is 250,000 CFS, cubic feet per second. That's the flow, which is a huge, major river. And then we have here the San Joaquin River with all its tributary. Notice they're coming from high elevation to low elevation to Suisun Bay to the bay and then to the ocean. That's the natural flow of rivers, correct? They start at location and eventually going to lead into the ocean, correct? In this case, Redding, Sacramento, San Francisco, Los Angeles, San Diego. Why is this line important? I don't know if you heard that there was a petition to divide California into 2 states. Do you know where was the division line? This line. They want to have 2 states instead of 1 state. Why? Because of this number. See this number? What does it say? 56 MAF. MAF means million acre feet. Are you familiar with this unit? What is a million acre feet? I did the conversion at the bottom. 1 million acre feet equals 1,200 million cubic meters. Most of the units I'm going to use, they're going to be in customary units, inches, feet, acres, and so forth. Wherever it's relevant, I try to convert to metric units. So I put things in perspective when it comes to Jordan and comparisons with Jordan. So this is 56 multiplied by that number. That will give you how much water generates in Northern California. This part is called Northern California. This is the Central Valley, and this is Southern California. Southern California still produces water, 15 million acre feet, but they need 29 million acre feet. So they have 14 million feet shortages. They don't have enough water. So what they do? They borrow water from where? From Northern California. They buy it, actually. They buy it. It's not free. It's not free. It's the same state, Northern in California, they sell water to Southern California. Luckily, I am on this side of the fence, on that side, so I sell water to Southern California. Keep that number, keep this number in mind, and keep this number in mind as we go more and more depth into these numbers and in details. Does this number has any significance in the water portfolio in Jordan? What is it? Similar to Jordan. Jordan about 1,400 million cubic meter supply. 1 billion? Total. Okay. That's the number I came up. I came up with numbers from one of the documents I obtained from a certain governmental agency in Jordan. So those numbers I'm going to use, they're not even close to the 1 billion you're talking about. Anyways. Okay. There is also the American River, San Joaquin, and Colorado River. I did not show Colorado River on this map. Where would the Colorado River enter California? Right there. In Southern California. It crosses many states and it leads to into the water portfolio. Do you remember when I told you we have 4 levels of governance in California? We had the federal, the county, the state, and the city. Surface supply under federal jurisdiction, there is 200 surface storage reservoirs, capacity 50,000 acre feet. What was the acre feet we talked about? 1 million? So that is equivalent, the storage, 200 reservoirs have a capacity of 50,000 acre feet, which is about 60 million cubic meters, one reservoir. That's under federal jurisdiction, which means that the federal government operates, maintains, and uses that water. Then, under the state and local jurisdictions, there's 1,000 surface storage facilities greater than 50,000 acre feet, which is greater than 60 million. So if you think about it, how many reservoirs or storage facilities in California, all in all, under federal and state jurisdiction? 1,200. In Jordan, how many reservoirs do we have? 17. Allah, Mashiach, alhamdulillah. This figure shows the high column, the light blue, and the dark blue. The light blue shows how much water is generated from historical average for that year. The dark blue line represents how much storage in those reservoirs. So in this case, what is percent difference between this number and that number? 50%. Where did this water go? If the reservoirs only can handle this much, what happened to that water? Ocean? Evaporation. No. Evaporation of that magnitude of water would require that you have the sun close to Earth to be able to evaporate this much water. Anyways, so in this case, there is surplus here, there is shortages here. Do you remember the drought that happens in California before this event or this season? That's when it started, in 2007. Not enough supply, not enough supply, not enough supply to get us back to the historical average. So we have enough reservoirs to store water to sustain California with all 40 million population and its agriculture and its environmental for 3 years, 3 consecutive years. So if we have an average year of rainfall in California, we have enough reservoirs to store water to be enough for California to use for 3 consecutive years. So if it didn't rain for 3 years, we don't have any problems in California. These reservoirs are located at key locations in California. Do you remember the line? Where was the line drawn? Here? 1, 2, 3, 4. Look at these numbers. That is Shasta. That's the size of Shasta, 4.5 million acre feet. 1 million acre feet is 1,200 million cubic meter. That's one reservoir. This Shasta reservoir is owned and operated by the federal government. Remember, federal, state, local, and so forth. So this is owned and operated and built by the state. Lake Oroville, which is this dam located here, has a capacity of 3.5 million acre feet. That's operated, owned, built by the state of California. The federal government has no jurisdiction over that dam or that reservoir. The majority of the reservoirs are located in the Central Valley. Look at these locations. Central Valley. Only 2 on the other side of the mountains. Most of the storage occur in these reservoirs, and after we collect that water from these reservoirs, we move it along the aqueducts. Remember the 701 miles, cost of operation 600 million? Remember that? It's this aqueduct that passes through California and then gets to this point, which is the lowest. There's a pumping station called Edmiston Pumping Station. Pumps water over the mountains and stores the water where? Into these 2 small reservoirs. And when the state of California, in Southern California, they need water, they release water from those reservoirs. That pump station, Edmiston Pump Station, pumps 10,000 cubic feet per second. They have 5 of those pumps. The capacity of the aqueduct that moves water from northern to southern California is 10,000. So those pumps are capable of pumping the entire content of the aqueduct to southern California in a second. The intake of the pump, where the water goes into the pump, if you have 2 adult males stand on top of each other, they pass through the pipe for each single one of those. They bought them from design in Japan to improve the efficiency from 65% to 85%, those pumps. Because you're talking about millions of gallons of water if you go from 65% to 85%. So they improve the efficiency, they bought those. I'm not gonna go through a lot of details about the size of the reservoir and how much water in the reservoir, but basically, quickly, the yellow column represents the design capacity of that reservoir. The blue line represents the amount of water currently on this date, on this hour, when you access that information. And the red line, on this day of every year going back to the beginning of the construction of that reservoir, that's the average. The red line is the historical average. The blue line is how much water we have now, and the yellow line represents the total capacity of that reservoir. When we have a drought, those blue lines fall below to these levels. In this case, this reservoir, 11% above historical average, the blue above the red line by 11%, and so forth. We would like to have all of these yellow lines covered by what? Blue. All the reservoirs are full. That will help us. Remember the Sierra Mountains? Are you familiar with the recent fires in California? Where did those fires happen? Forest, which one? northern part of California, right? Chico, near Chico. Chico is, remember when I showed you the map? California, Chico was somewhere there. These are the mountains of Chico. Fire, snow, snow, fire. This road leads to one of the clearest lakes in the world. Anyone knows what is the name of the lake? Lake Tahoe. It's a closed lake between Nevada and California. It's one of the bluest and clearest lakes in the world. This road leads to that lake. Look how high the snow. Guess how high that snow is in that picture? 15 meters. It's about 50 feet of snow. That's on an average. So, snow represents a big supply in California water resources. Also, the surface reservoirs we store water from runoff. So, snow and surface water are very important in this case. Look at this guy, standing on top of a beetle, a bug. Groundwater as another supply of water resources in California. This is a busy map. You cannot tell which is which. So I took a smaller map to show the regions in California. There are 10 hydrologic zones, so 10 zones of groundwater basins in California. In this case, if you look at this small map, that's your Sacramento, that's your San Joaquin, Tulare Lake, South Coast, Central Coast, San Francisco, North Coast, North Lohanton, South Lohanton, Colorado Basin. So these are the 10 groundwater basins in California. Now, a few years back, the state used to do, when they used to prepare their water plan, they used to rely on a statewide analysis. But that was crude and not very accurate when it comes to hydrology. Because hydrology is a science of guessing. I'm trying to guess what's going to happen in the future. Based on givens, which is data I have now, I'm trying to predict the future. So that's what the state used to do. But in recent years, to make it accurate and to provide high level of accuracy and confidence level in the data, they start relying on hydrologic zone analysis. That includes surface, groundwater runoff, evaporation, and all of that, through a hydrologic zone instead of statewide analysis. Now, the last part, all these parts we talked about, these are non-sustainable resources. Can you make rainfall? Cost effectively, can you make rainfall? You can, but it's going to be very expensive. You'd rather buy bottled water from stores. It would be cheaper than making rainfall. So in this case, all these resources we talked about so far are non-sustainable resources. They come in a year and then they disappear. Use them and they're gone, unless you recycle them or treat them or do other issues with them. Then we need to create a sustainable supply, which means that this supply I have to rely on it day in and day out. As a planner, I want a number that I can rely on. I'm getting 100 gallons, then I will expect to get 100 gallons. With rainfall, it's not always 100 gallons. It could be 150, it could be 50, it could be nothing. So having a sustainable resource like desalination, I'm going to spend a little bit of time on desalination because I think that's where Jordan should move in the direction of desalination. Even though we don't have oceans, we don't have a lot of water, but we can utilize this technology efficiently to produce more sustainable, reliable water. Started in California in the 60s. Desalination started in California in the 60s. In 2009, they have 26 desalination plants. Out of those 26, 20 for groundwater, 6 for seawater. The 26 treatment plants, they have 20 for groundwater and 6 for surface water, which is ocean water. They produce a small amount of 82,300 acre-feet per year. Remember what is a million acre-feet? 1,200 million cubic feet. That's a fraction of that number. So it's not enough to provide a state of like California or a country like Jordan with enough supply to augment the difference between the supply and the demand. Seawater desalination plants produce even smaller than the groundwater. Why did California rely on groundwater in desalination rather than the ocean? They have the biggest ocean, one of the biggest oceans, the Pacific Ocean, just around the corner. You walk into the ocean, 70 miles away from Sacramento. Less saline in the groundwater, okay. Quality of water, which is salinity. Anything else? Close where it's needed. If I'm a farmer, all I need is to dig a hole, throw a pipe, a pump, and I have access to groundwater. Compared to, I have to go to the ocean, get all the permits required, and get water, move it in pipes to the treatment plant, treat it, and then pump it to where I need it. It's inefficient. So in this case, it was more convenient to have groundwater as a source of desalination. Basically reduce the salinity of that water, improve the water quality, to have an available or sustainable resource. Why desalination is important? This. Increase the water supply. As I said, remember I said 100 gallons? Every time I expect to have 100 gallons through desalination or through other processes. What does that mean? Water reclamation and beneficial use. When I say I reclaim something, if I told you I reclaimed this chair for Saad مريان, what does that mean? Reclaim, which means that I took this chair for Saad مريان. That's Saad مريان's chair now. So when I take this water, reclaim it, which means that I take this water, process it, treat it, and create a new resource for places. Beneficial use. After you claim the water, clean it, I can use it for farming, I can use it for urban, I can use it for environmental, for any other resource that I have, I can use it. This is very important as water resources planner. What is that? Supply reliability, which means that if we have a drought, we don't have water. If we have rain, we don't have water. But if we have desalination, I know how much water I'm going to get every year, correct? So it's going to improve my odds of planning or creating a system that can be sustainable. So when I'm going to tell you, I'm going to get you 100 liters per day as a Jordanian, this means that based on that, I guarantee that I'm going to be able to send you 100 liters per day as a Jordanian. So that will provide me with enough confidence in my system that can meet all the demands. If you have more water, of course, it's going to improve water quality. If you improve the water quality, you're going to improve or protect the public. If you drink contaminated water, you get sick. If you drink what? Clean water, you don't get sick, correct? So that feeds into the public protection. Why desalination is not the method of choice in producing sustainable water? Cost. First thing is cost. These are examples of desalination of groundwater. It costs $500 to $900 per acre foot. Wastewater, $500 to $2,000 per acre foot. Seawater, $1,000 to $2,500. That's why California does not use seawater to produce sustainable water from oceans, because it's very expensive. That's one thing. What do you think? We talked about surface water, correct? All these rivers in California and all these reservoirs. What do you think the cost of the same acre foot from surface water in California compared to these? Give me a number. 100? 200? 100? Well, assuming it's clean water, ready to use, like when we produce this water. Less than this. Definitely is less than this. In a wet year, the acre foot is $200. Compared to the cheapest is what? $500. in an average year between $300 to $500 an acre foot. In a dry year, you're talking about $1,000 an acre foot. So if I am a farmer or a water user, which one do you think I should use first? Surface, which is cheaper. So why do I have to worry about all these sustainable resources? But the state of California required by law in 2020 to have 20% of its water portfolio coming from sustainable resources. They have to generate new water instead of using the same exact water. Then the cost is a problem. This part is bigger problem in California and bigger problem in the federal government. Why this is a problem in California? Environmental impact and permitting. Are you familiar with the brine, which is this? Brine, or the concentrate after we remove the salt from the water, to obtain or get a treatment plant, desal treatment plant in California, the process could take up to 10 years. From the day of starting the permit till you end the permit process to start the construction of the project, 10 years on the average. Why? Because the federal government has certain environmental requirements. California added another layer of environmental requirements on projects conducted by the state of California. So the entire country operates under one set of rules. California operates under two sets of rules, self-imposed rules to protect the environment, wildlife, and species in California. The other problem is this, seawater intake. Where do I place the seawater intake? How far in the ocean? How deep in the ocean? Is that going to impact navigation? Is that going to impact fisheries? Is it going to impact the temperature of the ocean? All of these issues you have to think about. You have to get a permit to do that. Then after you treat it, you have to get a permit to discharge of the brine, which is the concentrate. What do you do with all this salt? I ask my students, what do we do with all this salt? Someone said, open a company, sell salt. I said, how many bags of salt do you use a year? I said, I have a box that I haven't finished in 4 years of college. So having a salt company is not going to get rid of all of that salt and coming from the ocean. احكي بالعربي بفهم عربي احكي بالعربي ايوه. Okay, the problem. That's going to create imbalance, chemical imbalance in the ocean. That will impact wildlife and fish. Maybe. It is not allowed. High energy intensity. Seawater desalination required high energy. It takes a lot of energy to produce the acre foot we're talking about. Carbon footprint. Are you familiar with this term for reverse osmosis treatment plants? Carbon footprint. How much you produce CO2 from the activities you do as a human, from driving your car, from heating water, from cooking, from all these activities. That's called carbon footprint. To create water from a reverse osmosis treatment plant, it takes, for seawater, for brackish water, which is the easy to treat, is about 800 kilowatt hour per acre foot. For seawater, it's 4,000 kilowatt hour per acre foot. That's not only the problem. The problem is the air quality, global warming and climate change. Because the more you use energy, the more of CO2 you release into the atmosphere. The more you increase the temperature of the earth, the more you create problems and melting of snow caps. So basically it's a cycle, never-ending cycle. The more you do, the more you damage. In this case, this is what's important for the state of California. This number and this number. How many grams of CO2 equivalent per kilowatt hour? How much grams of CO2 you release into the atmosphere? The state of California, under the governor, who's the governor? Do you remember who's the governor? Arnold. Yes, Arnold. He created the most stringent air quality laws in the history of California. He wants to bring the state air quality to the standards of the 1990, where there is no this revolution of cars and industry and so forth in California. So that's something I give to him. Other than that, no. This number, 900 grams of CO2 equivalent, the discharge of the concentrate. تفضل. استعجل؟ Okay. Fine, I can stop. I still have the demand, the issues of concern, and then the parallels between Jordan and then the solutions. هذا يا سيدنا العزيز الفيجر هذا اللي فرجيتك اياه او اللي مبين هون هذا بيسموه الباترفلاي figure because it shows all the supply sources in California. The other side of it shows the demand sources. I'm going to show that in the demand sources. The supply is diverse, as you see, from different sources, state, local agencies, and so forth. This figure shows in the state how diverse the supply with the demand. They don't match from surface, groundwater, surface, and groundwater from surface, sustainable, desalination, groundwater pumping, all of these are from different sources. This is basically a summary of the water supply in 3 different years in California. 1998 was considered a wet year, 2000 an average year, 2001 a dry year. In this case, that's how much a million of acres of water generated through those years. Look, it's almost 100 million acre feet, and it goes down the year. And now with the recent drought, they create a new definition of a water year. It's called critically dry year. It's on this side, where the water is very scarce in that year. Demand and use. Do you remember I hit this part? This is how much water they use. This part is the urban demand for homes, drinking, sanitation, irrigation, cleaning your house, businesses, and so forth. That's called urban in the state of California. It's about 8%, which is about 11, 12 million acre feet. This part from here all the way to the blue line, that's your agriculture, water demand. The blue line here is your environmental. In the state of California, there are 3 water demands: urban, then agriculture, and finally environmental. Environmental and agriculture takes the largest amount of water use. Urban is consistent throughout the years, whether it's a wet, dry, or any year. This is the water demand by hydrologic zone. If you look at that, in Sacramento, 2.9 million, 1.74 gallons per day per capita. This is how many gallons? 1 gallon, how many liters? About 3.7 something. So in this case, close to 800, 1,000 in some places. That's how much water they use in California. At least 600 gallons, 600 liters per day per capita. What is the water use in Jordan? 100? No, it's not. 61, based on the 2017 surveys. 61 liters per day per capita, compared to 800. What?
68 liters per capita or
61 liters per day per capita. That's 2017.
Yes, in the design we take for urban areas 120 ل 120 لتر per capita per day. نحسب منهم 40% اللي هو اللوسز unaccounted for water. فضل عندك ال 60 اللي بيقولوا عنها، رغم انه احنا بنقول اللوسز هاي اللوسز مش رايحه، لان اللوسز ناس بيستعملوها بس بتاعوش ثمنها، وبالتالي you cannot assume it as losses. يعني ال 100 او ال 85 is reasonable number.
Usually it is considered
The next
50 liters per day per capita, generally speaking, in all over the world.
Yes, here?
Usually it is considered 250 liters
Yes, yes.
per capita.
which is the standard design for urban water is 120 gallons per day per capita. 120 gallons.
How many gallons? How many liters? I understand only liters.
اضرب 3.76. المهم agriculture water use. There are 88 farms, 9.2 million acres irrigated land, requires 34 million acre feet, 40% of the water use. Remember this number, 42%. Agriculture provides California with almost 37 billion in gross income. That's on annual, that's on the average. And then in indirect industries related to agriculture is 100 billion. So the agriculture impact in California is about $140 billion. Environmental and stream fish and production use about 39 million acre feet, 47. Remember, we have three water uses: urban, agriculture, and environmental in California. Groundwater regions, we talked about that before. 70% of the use comes from groundwater in California through those 7 or 10 hydrologic zones. That's a comparison between the different uses in California. That's the demand, and that's across the three different examples years: wet, average, and dry. 8%, 11%, 13%. Agriculture 28, 42, 52. Environmental 64, 47, and 35% of the amount of water available for that year. The water changes from one year to year. It could be 1,000 gallons, it could be 500 gallons, for example. But that amount percent from that water. Issues of concern in California. There are a few issues that I focused on in this presentation due to time limitations and due to relevance to the topic I'm talking about. Those issues are floods. California is known for its floods. Of course, there's fires, but fires is not relevant to my presentation, so I'm gonna not talk about fires. The Sacramento-San Joaquin Delta, drought, which is lack of water. Climate change. Under climate change, I picked two important topics: temperature change and sea level rise. These are the issues of concern. There are other issues of concern, but I'm not gonna talk about those in my presentation. First, floods, first issue of concern. California is known for floods, historically, from centuries ago. In December 1861 to January 1862, during this 2-month span, there was 45 days of continuous rain. They called it, or they name it as the ark storm. It has biblical references, the magnitude of the rainfall as the ark storm. I'm gonna show you a video, but unfortunately, there is no voice. It's about 3-minute video, but there is no voice. Can you see it? I tried.
How many inches do you see?
I'll talk about it in a sec. You see it now? You see it? Come on. I don't think it's not projecting. Technical help?
لا هو المشكلة إنه بالديسبلاي أوبشن بدك تحط إنه بدك دبليكيت على الشاشة وعلى السكرين
لا.
ولا على الواحد نحاس.
هي
تلاقيها دكتور.
مش اشكال. Don't worry about the video. خلاص. مش اشكال.
خلاص please compare back to your.
All right. The video I wanted to show is talks about an arc storm that rained for 45 days, and the amount of rainfall was 10 feet. Those 45 days, which is 10 feet, which is about 3 meters of rainfall, continuous rainfall until it's 30 feet. That caused the entire state to bankrupt, flooding San Francisco, Sacramento, Los Angeles, San Diego. All the urban areas were flooded, damaged all the crops, damaged all the infrastructure. So in this case, the state is wiped out. In 2007, we had a conference related to the arc storm, completely dedicated to the arc storm and how can we predict and prevent the arc storm. The video talks about some solutions of the arc storm. If you're interested, I can show it to you at the very end of the presentation on my laptop. If you notice, California has history of rainfall and history of flooding. But the problem is not the flooding. The problem is managing that flood. We can't stop floods. We can't stop rainfall. But the issue is to manage those floods. That's the key issue with flooding. Certain flooding in California that wiped highways, roads, bridges, like what happened in Jordan a few months ago, right? When we have in certain locations in Jordan. So water does not differentiate between Jordan and the California bridges. It just wipe out all these bridges. There's another video here. I don't know if it's going to work. If I clicked on it, is it going to project? Try it. Let's see.
ولازم تطلع اول شيء من
أنا طلعت هيني هذا هو.
تشغل الفيديو بس هو
أنا مشغل الفيديو بس it's not projecting the video screen.
ولا شغال.
Yeah, شايف؟ بدي project this on the screen behind me, please. ما ضبط. خلاص مش اشكال. انا بحكي لكم عن الفيديو شو الموضوع. انا بحكي لكم عن الفيديو هم بيشتغلوا عليه. الفيديو يا سيدنا العزيز، الفيديو بيحكي عن وين هو؟ ايوه هون. لا هي لازم تكون projected عشان يصير. هيو in the background. هيو in the background. I think هيو الفيديو. Did you close it? Okay. Hold on. It's this video I want to show.
هي Alt F8 بس بدون.
هذا الفيديو. There's a road coming this way, and there is a way to drain the water under the road. If you notice, the mission failed because there is water above the road. You should not have that. Water always has to go under the road with a culvert if you design hydrologically correct. See this cone? That's where the low point. In this case, that's the entrance of it. Now, water is coming back from the road because there is enough capacity to go under the culvert through the road. You see this debris? This tree is wiped out. This debris is taken in. When we design culverts or drainage under roads or highways, we add 25% capacity, extra capacity for blockage and other debris accumulation within the culvert itself. So now, you see this bubble? The road is destroyed or damaged because of the force of the water going between the asphalt and the subbase and the culvert. Do you know what this culvert is? Which is a pipe going under the road. So now there is no water, which means that culvert has capacity. No, the road is being destroyed, the subbase under the asphalt. So you're creating an open channel in a culvert or a pipe. That's the downstream end of it. I'm going to accelerate it a little bit, move it faster. Some of the road damaged. More damage to the road. So now, where is the culvert? Nope, not yet. Still there. It's right there. That's the culvert. See, that's the pipe that, this is about 6 feet. Corrugated steel. Corrugated steel, not PVC. Corrugated steel. So now, the culvert is washed out, and the road is damaged. That's when we do not do hydrology well, Dr. Radwan, صح? So flooding, it happens, whether in California or in Jordan. The only way is to try to mitigate, reduce the effect of flooding. Another problem with flooding is this. See this part? Should be like this part. That is Sacramento River. That's a floodplain, natural floodplain, and this is a natural floodplain. Urban sprawl caused these people to build close to the river because it's a sign of a high status. I have money, I can have a waterfront home, like a إطلالة هون بالأردن على جبل or something. The same idea. المهم, this create a problem. You see this part here and this part there? That's called the levee. Those levees are designed to protect the floodplain and protect homes on the other side. Basically, earthen dams, compacted clay or soil or layers of all of that. Having those homes require that this levee to be higher, which means increasing the velocity of the water in the river, erosion and damage to the river. So it has other consequences. But having homes close to the river, that creates a potential for more flooding. This is an area about 20 minutes where I live. It's called Natomas. It's like a bowl. The city is like a bowl, surrounded by water from all sides, which is the rim of the bowl, and then everything the city is in below. If any failure of water from these places or these levees, all the water is going to rush in and fill that void or low elevation. This city, this is where the Sacramento Kings basketball team play. That's the arena for the Sacramento Kings. This is a fire station. That's a new construction. When we have a flood, we need to have access to emergency planning and evacuation and recovery of humans who are suspended by the flooding. In this case, if one of those levees surrounding the city of Natomas failed, this is the consequence. This is going to happen. The whole Arco Arena is going to be underwater. These people in this building were not going to be able to evacuate. The fire station is gone. So the emergency facilities is not available to basically help people and rescue them. So it's gone. Second issue of concern, the delta. I want you to think about this. You have a door, and you have the frame of the door. To connect the door to the frame, what do you need? Hinge. Nailed, right? Hinges. So the delta is designed as the hinge in the California water system. Without the delta, the California water system does not work. Why is the delta also important? Provides fresh water for these uses, provides flood control, drought management. This is the delta from outer space. The Sacramento River, the San Joaquin River, those blue dots, islands for agriculture. The blue line represents waterways. Then the water flows from the delta to Suisun Bay, and then to the bay, and from that point to the ocean. That's how the water flows. We need levees to protect the islands of the delta. This is what you saw from the islands. The black lines represents levees, which is compacted clay layer, 30 feet, 40 feet high, to prevent the water from going from the river or the waterways in the delta into the islands of the delta. That will create flooding and damage to fertility of the soil. This side is for non-levied projects. These are levied projects. And this represents how they used to build those levees. That's the water, and this is the island on this side. That's how they used to build levees, and that's now how we build those levees. In the old days, they used just to pack sandbags on top of each other. Here, they built and constructed a levee according to engineering standards and according to the approved conditions of the soil. Another problem in the delta called subsidence. Subsidence is the lowering of the soil. You take a certain elevation and the soil starts getting lower and lower in elevation. In this case, pre-1850, this is how the islands used to look like. And then this is after existing condition. What is so important about this date? That's the gold rush. When people came from the east of the country to California to mine for gold. In this case, because of their agricultural practices and because of the nature of the soil, which has organic matter, one of the practices they used to clear the fields, they used to burn them. Instead of using agriculture equipment, they just burn the entire field after they finish the season of agriculture. That will take all the organic matter from the soil and evaporate it. So that lowered the soil. In this case, in some places, the soil is lowered up to 30 feet. Saltwater intrusion. Remember I told you water goes Susan Bay and then to the ocean? That's what the ocean replies with. We send this much water, 170,000 cubic feet per second. The ocean replies with 2.0 million cubic feet per second. Imagine. The ocean pushing in and the islands are pushing out. Which one do you think will win? The ocean. So the problem is the saltwater intrusion. The ocean water is salt. The water in the delta is fresh and will not, they use it for agriculture and they have wildlife and fisheries. So that creates a problem when salt water comes in here. Before, the solution that the state came up with, the saltwater intrusion used to cover the entire delta from the ocean, which means it was not appropriate for irrigation and for agriculture. The solution was reservoirs 2, 3, through 3 parts of the delta. When the ocean pushes in, they release fresh water from those reservoirs, they push the ocean back. This process on a daily basis. The Department of Water Resources, they have an entire team, division, that is responsible for this. How much water we should release and how much water from the ocean we should get.
I wonder, how come the water from the ocean goes from a 0 level up to the head? How come?
No.
High level to low level.
The
Are you talking that the ocean water comes from low level to high level? How come?
if you remember when we talked about the islands of the delta, and the delta we said it's flat, and the mountains are the Sierra Nevada mountains, which has nothing to do with the delta. The delta between 2 rivers, the Sacramento and the San Joaquin River, which is closer to the ocean. And that's what happened when we released water from all those reservoirs that basically created a control for the saltwater intrusion. The third issue of concern is drought. If I ask you what is drought? Lack of water, no rain, tasahhar, correct? How do we define the threshold for a drought? When do I declare a drought? When it rains 50 inches of rainfall or 50 millimeters, or when it rains 200 millimeters? The drought is a relative term. The drought in Jordan is not the same as drought in California, it's not the same as drought in New York, it's not the same as a drought in Arizona. So the drought is a relative term, like good and bad weather. Bad weather is for you something, bad weather for me is something else. So drought is different term. Based on the standards we set, if I set, I am getting 90 millimeters of rainfall per year in Jordan, anything below that is a drought, anything beyond that is a wet year or a good year. The entire country was not under drought. California was under severe drought. This purple or burgundy, burgundy means drought. The same thing here. We start creating different terms to differentiate how severe the drought is. Instead of a drought, we have moderate drought, severe drought, extreme drought. Those terms, I served on a committee, the governor's drought task force, and we have to come up with these terms to make it easier for the normal person to understand we have a problem. If we say drought, they think, oh, it's a drought, it's not a problem. It's extreme drought, they start thinking 2 million times before they use a certain amount of water. This is the progression of drought through the beginning of the 2011 year. In this case, the governor waited all this time to clear a drought in February 25th, and after this severe and extreme drought, he declared we have a drought. In this case, he will get money from the federal government, and he forces citizens like me to reduce the amount of water they use. That's what happens when you have a drought. This is supposed to be a farm, and this is supposed to be a kind of a water holding area for agriculture and farm animals. Those counties within California, they almost ran out of water. Imagine all that vast amount of water we talked about. They were about to run out of water in 3 months because of the severity of that drought. The fourth issue of concern is climate change. Climate change, you think about it, I like this. Climate change is an angry beast. Think of the angriest beast you could find, and you try to poke it with a stick to fight it back. Do you win? You don't. So that's what happened with climate change. We can mitigate the consequences of climate change, but we cannot stop climate change unless it's a global initiative to reduce greenhouse gases and global warming. And of course, the United States withdrew from the Kyoto Treaty and the Paris Agreement, and Mr. Trump does not believe in climate change. Consequences is increase in 1.5 to 5 degrees Celsius. Average rainfall changes, but the pattern of rainfall changes. Early floods, because our system designed to take this slow snow melt and then we use it for the demands, but now we are getting flash flooding and sudden flooding like what happened in Jordan in recent days. The snowpack, do you remember the Sierra Mountains? We said 30 feet, 40 feet of snow. In this case, it would reduce to 3.8 to a million acre feet, or 25 to 40 million acre feet. And sea level rise changes between 8 to 14 inches in the San Francisco Bay. This is the temperature measured, and this is the projection. That's how much we know, and this is what expected to go from 0 to 6 degrees Celsius change in temperature from 2000 to 2100 years. So in a span of 100 years, we're going to increase the temperature of Earth by 4 degrees Celsius. Sea level rise, you familiar with this? I've seen this before. Golden Gate Bridge, famous. They have a gauging station that monitors the sea level level on a daily basis. They start monitoring that 100 years ago. So this is the measured data, the sea level rise at that gauging station. If you notice, it's increasing. The trend is increasing. Now, from this trend, we projected in the future how much will that change if we maintain the current level of climate change without doing anything. These are the lines that represents different scenarios, climate change scenarios. And this is the accuracy band we look at. Look at it from 0 in 2000, it's going to get to 3 feet, 4 feet of sea level rise. And that's going to cause a lot of problems on the coastal regions on either side of the country in the United States. East Coast and West Coast. Most of these countries will be inundated with water or flooded with water. Because rising, when you increase the temperature of Earth, it's going to melt the snow in the snowpacks in the northern and southern part, and it's going to mix with the ocean of the water will rise. With the sea level rise, this number, 2.3 million cubic feet per second, is going to be somewhere there. So no amount of reservoirs or water will be sufficient to combat saltwater intrusion. So basically California will be under salt water. And some solutions, and some people actually call for that solution. Let the ocean water come in. It used to be natural marshlands. That's the way it used to be before urbanization. Used to be ocean water comes in and then leaves, tidal wave, every single day. One of the solutions, instead of investing a lot of capital, a lot of money, is to let the process take its course. Don't fix it. These are kind of a simulation of what happens with the sea rise level, what happens to the islands of the delta. Delta today, that's with 1 foot of sea level rise. That's with 2 feet of sea level rise. The majority of the islands in the delta will be damaged with water or flooded with water. Now, a consequence of the climate change is greenhouse gases that emits to the atmosphere, that is CO2, and that would cause the ozone to degrade, and it traps temperature within the Earth crust, and that raises the temperature of Earth. In this case, which one do you think contributes the least to emission of greenhouse gases? Let me define those. Transportation, power generation, industry, agriculture, solid waste, landfills. Power generation is the least? The most? Let's first do the least. Agriculture is the least. Anyone else? Come on, guess. You have 5 choices. Your chance is 20%.
Waste.
Waste is the least. أعطيتك الأنسر أنا. It's waste, the lowest number. What is the second? Agriculture, 6%. Industry, 20%. 33% energy, and transportation is 40%. You have 40 million people drive cars, almost. So, if we solve this issue in California, transportation, mass transit system between major cities like San Francisco, Los Angeles, Sacramento, San Francisco, and then San Diego, San Francisco, we reduce 40% of the greenhouse gas emissions from the state of California. The Sierra Mountain snow, this is 100%. With climate change, a certain low warming range, that's a certain scenario. 60% of the snow disappears. Under medium warming, 80% disappears. Under extreme, there will be no snow on the Sierra Mountains. And that's how many people in California gets their water from the Sierra Mountains? 15 million. So you wipe the water for 15 million Californians. Jordan's parallels. You might help me with this one. I talked about California, now it's on you. 2017 water year. Jordan's water supply is 1,015 million cubic meters. Folsom Lake, one of the reservoirs in California, is almost that. Jordan water demand is 1,412 million cubic meters. The deficit is about 400 million cubic meters. The water deficit in Jordan is far more than the deficit in California. Even though the population of California is more, the size of California is more, and the amount of water used per capita per day is a lot more. But in Jordan, the deficit is higher. Water sector expenditures, Jordan, they spend 500 million JDs, which is equivalent to 650 million US dollars. California spent in the billions of dollars on their water infrastructure and the water sector. So there is a difference between the investment in California and Jordan. California invests in the water sector way more than Jordan. The last, through taxation and bonds, the last water bond I was actually pushing for it, the state was created a $10 billion bond, which means that this water is only allocated for water projects. 10 billion. That's one bond. And now we have another one for $15 billion for infrastructure related to water resources. So if you want to specialize in California, it's water resources, not structures. Okay, water use per capita. Water use per capita in Jordan, based on the reports that I have, says it's 61 liters per day. Water use per capita in California, on the average, exceeds 704 liters per day. Water losses in Jordan, 65 liters per day per capita. If you look at the losses, 65, and the usage is 61, which is almost more than what a person uses in Jordan. So if I fix the leaks, I generated twice the amount of water that people can use. Well, agricultural water use in Jordan, 700 million cubic meters per year, which is 60% of the national water in Jordan. 60% of the water in Jordan is dedicated to agriculture. These are not my numbers, by the way. These are from Jordanian reports. Agriculture in California uses 40 to 60%. That's normal here and there, but there is a problem. I'll talk to you about it in a second. Jordan's agriculture contribution to the economy is 3 to 4% of the GDP of Jordan. Jordan's GDP is $44 billion, which is 3 to 4% of that, using 60% of the natural resource, producing 3% of the GDP of Jordan. Does that make sense? I'm going to leave that to you. I'm not going to discuss that part. California agriculture contributes direct and indirect receipts in the close to $140 billion. California GDP is $2.9 trillion. Remember, it's the 5th largest economy in the world. So there is an imbalance between the production and impact on the economic situation with the resources used to allocate to create that resource. Decisions in Jordan are centralized, which makes it easier compared to California, where the decisions are localized. The decisions start at the city, goes to the county, goes to the state, and then goes to the federal government. In Jordan, is the opposite. Goes from the top, it trickles down. Makes it easier to make decisions on policy changes, but obviously there's something is not working. Long-term strategy to improve the water sector and not the bandage solution approach. There, if there is a problem like the Oroville Dam with the spillway, when it failed, they just took the entire spillway off and they did an entire hydrology report to fix the problem. Here, if there is a pipe leak in Jordan, they just wrap it and say, it's good, it's solved, it's gone. I'm exaggerating, by the way. Solutions. Surprise. I want you to think about this word for a second. Why am I saying surprise in the solution? Shouldn't we offer solutions? Possibly. We're guessing. That's one of the solutions. That's the cheapest solution, actually. That's one of the scenarios or alternatives you always have to evaluate. If I did nothing, is that going to cause any loss of life, or it's going to cause economic impact? So, why it's surprised? There is no one magical solution. The solution for Jordan, northern part of Jordan, is not the same as the solution in the southern part of Jordan. The same thing with California, the same thing with New York. So there's no exact solution. You could say, okay, I'm going to fix the problem this way every day. So I'm going to measure it a meter, it's going to be a meter all over the world. It doesn't work this way. There is no one-size-fits-all mentality solution. If I fix it this way here with $1 million, there it's going to be $1 million. No, might be here $1 million here, might be $100,000 there, or $10 billion in another place. So there's no exact fit size for all of these. A holistic strategy for water management. Holistic means system-wide, not looking on the pipes by itself, not looking at the reservoir by itself, not looking at the delivery. So look at the system, entire system. How can I make this system better? From the supply, to the delivery, to the use, to the excess. California. They use the idea of these reservoirs, I talked about for saltwater intrusion, they use it for flood management. Their purpose was for flood management, to prevent flooding in Sacramento. Now they use it for saltwater intrusion. They use it for drought management. They use it for recreation. They use it for multiple uses. They started with one concept, flood control, to prevent flooding. Now they ended up with many, many concepts they use. Now, these are strategies in the state of California. Pick and choose which strategy you want to follow. There's no one single strategy that will fix the problem. I could pick one that will help me in one problem. Pick two will help me a little bit. But pick those, all of them, it's going to be what? Extremely expensive. As an engineer, we always look at the cost and benefit of a project, correct? If the cost is a lot more than the benefit, we find another scenario for the project, correct? So in this case, this is the laundry list of things you could do in California to manage your system. Cows in California, they fly. Why? Because what you do on land impacts your water. So that goes to where? To the city at local planning level. My decisions at the local level impacts what happened in the ocean. So that's why if you have a cow, it's going to basically be swimming with the dolphin, because everything from the cow is going to go where to? The water. Now, Jordan. There's a problem in Jordan. What is it? Sudden population growth, basically explosion, which is, in my opinion, is a political decision. Water managers have nothing to do with that. They force on us as managers, okay, we're getting 200,000 a new population. Good luck, fix the problem. And we have to deal with it, correct? It's difficult. We have to adjust and be able to manage, but it's difficult. In California, the same thing. But in California, it's the opposite. We lose population. But in the next few years, the population of Jordan is going to increase by 10 million, by 25%. This part of the presentation, I really thought about it for more than 2 hours to think about the certain terms I'm going to use in a way that politically correct without offending anyone. First one, control illegal overdraft of groundwater. How many farms in Jordan, they have no regulation when it comes to groundwater? A lot. The second part, control the theft of what? Potable water, drinking water. How many people go around Sa'a to get water? There is a place I know I pass by every time when I go to my home in Naime, Bi'erbet. One of the people, there's a leak and they're not fixing it. You report it, they don't fix it. Reduce losses in aging infrastructure and efficient system delivery. Efficiency in your system, remember losses in Jordan, 65 liters per day. Water, a user, 61 liters per day. So if you fix that, you double the amount of water available for Jordanians on a daily basis. Also, the efficiency in delivery. Continuous monitoring and system automation to improve system efficiency. Do you think we have a way to monitor the flow of water in Jordan in portable networks? Do we know where the water is going? Where is the leak? What is the amount of the leak? We don't. We need a way for us to be able to monitor that so we can fix the problem immediately. Early warning system. To solve problems, when there's a problem, there's an alarm goes off, I know where is the problem. Also, prevent loss of life. If we have a warning system in Al-Bahr al-Mayyit, we could have warned those people, water is coming, run, head to high ground. Don't stay in the valley. Construction of new reservoirs that will increase the supply and reduce water deficit. It's expensive, but it's one of the solutions. Create sustainable water resources. major financial investment in the water sector, regional and national. Jordan has political boundaries. We have to have agreements with, in a way to bring us water that we don't have within our natural borders. And that's one of the projects that they're talking about, Red to Dead, the peace conduit, Red to Dead, conveyance, yeah. Improve financial and resources management. That goes into the illegal use and theft and so forth. So I'm gonna leave that to you to think about it the way you want. One thing I wanna leave you to think about is the agriculture sector in Jordan. Uses 60% of the natural resources with 3% contribution to the economy of Jordan. The Minister of Agriculture, the Minister of Water Irrigation, and the Prime Minister, Sultan Wad al-Urdun, they should sit and decide on a global strategy to address this issue. Either reduce the amount of water allocated to agriculture or increase the output, financial output from agriculture by using different crops, different irrigation techniques, different efficiencies, different processes, all of that. I finished my presentation. This is the title of my presentation. And this is my contact information. This is my email address at Cal State. This is my number in Jordan. I'm sure nobody will call me in America. This is my office number, and this is my mobile number. You have Facebook, and you have other ways of contacting people. So feel free to contact me if you have any questions. I'll try to answer as many as you can. Thank you so much for listening. I appreciate your time.
نشكر الدكتور سعد مريان على هذه المحاضرة القيمة. أول شيء باسمي الشخصي كصديق وزميل في الجامعة في مستوى البكالوريوس في جامعة العلوم والتكنولوجيا، وباسم اللجنة العلمية في شعبة الهندسة المدنية ومجلس شعبة الهندسة المدنية جميعا. ونشكر الحضور فردا فردا، ذكورا وإناثا، زميلات وزملاء. ونتشرف أول شيء نسمع مجموعة من الأسئلة ل10 دقائق، ومن ثم اسمحوا لنا نكرم زميلنا الدكتور سعد بعد إذنكم. إذا حدا عنده سؤال يتفضل.
احكوا بالعربي ريحوا حالكم، احكوا بالعربي، احكوا بالعربي ريحوا حالكم. ولا يهمك، انا احسن واحد يتكلم بالعربي. حياك الله.
ممكن تعرف بنفسك بس معلش، اللي بيسأل يعرف بنفسه.
انا فخري حموري من الخليل.
والنعم.
مهندس مدني متقاعد ويمكن اشتغل. خليني بس متعالج
يا سيدي والنعم منكم، تفضل.
بدي اسال اذا كان في كاليفورنيا مشروع زي مشروع ربط البحر الميت بخليج العقبه او البحر الاحمر. طبعا في فرق
نجمع الأسئلة مع بعض الدكتور أحسن شيء.
اوكي. اكتب انا.
في فرق الليمت حوالي 400 متر، وهذا اعتقد كافي للحصول على الكهرباء منه جنريت باور. وبعدين البحر الميت عماله بصير ميت، ممكن اعاده احيائه براسه مد المي اللي جاي من خليج العقبه، بالاضافه الى انه حسب ما قلت انه الان صار في امكانيه اندرور تسوي مشاريع زراعيه ممكن الزراعه فيها بميه البحار بالذات الرز. شو رايك في الموضوع هذا؟ هل في عندكم في كاليفورنيا شيء مشابه؟
أنا بجاوب بس ناخذ كمان مجموعة أسئلة.
خلينا نسمع الأسئلة. تفضل أستاذ. تفضل يا أستاذ حضرتك.
أنا فواز. أنا كنت متوقع إنك تحكي لنا عن الأكويدكت اللي بتجيب المية من فوق لجنوب كاليفورنيا. أوكي. أكويدكت. كاليفورنيا أكويدكت. مشابه لنا عشان نلاقي المية.
تفضل زميل.
اسمك؟
ميت خالص ميت خالص.
جاست كومنت يعني، انت مش سؤال. عندك سؤال؟ تفضل. معلش اذا سمحتوا خلينا نسمع بس.
سلطة المياه فيش
وصلت الفكرة.
تداخل بالصلاحيات، فيش بحس ما فيش مخطط شمولي للمياه في الاردن من الشمال للجنوب، كل منطقه بتشتغل لحالها، كل مسؤوليه لحالها.
تفضل زميل.
محمد بطاينة. غلبت الدكتور سؤال عن الفند ريزنج بشكل عام. حكينا ان المشاكل ممكن تكون عندنا اللي هي اللوسز اللي بتروح ديو تو ليكجز بشكل عام، او بالانفراستراكشر كبيره للفلدز او لاي شيء. فاي تيبس او ليسنز ليرند للفند ريزنج للميجا بروجكتس.
اوكي تفضل يا زميلي. ما سمعتش الاسم. ما سمعت الاسم عفوا. داليا. رانيا. لا مرشح انا واذاني مسكره.
هلا بس اول شيء بدي اشكر الدكتور سعد مريان عن جد فيري انترستنج برزنتيشن، ونشكر الاساتذه كمان اللي اعطونا الفرصه حتى نلتقي حضرتك.
تسلمي.
بس بدي اسال عن موضوع الديسالينيشن، اذا هو في عندهم ديسالينيشن بلانت اوبريتد باي رينيوبل انرجي، واذا في مجال انه يعني هيك تو ادوبت ذيس كايند اوف سيستمز ان جوردن. وبالنسبه للبرايم، اذا حضرتك عم تقترح يعني هيك any visible solutions to discharge it in Jordan، لانه it's easy مثلا بكاليفورنيا مع الاوشن، بس مثلا بالاردن انا I agree with you completely انه الديسالينيشن solution للاردن، بس شو بدنا نعمل بالبرايم؟ هاي شغله. وبالنسبه للبراكش ووتر، هل عندك حضرتك فكره اذا في visible quantities للبراكش ووتر بالاردن؟
هي 5 اسئله.
I'm sorry, يعني you can choose one.
شو وتر. تفضل زميل. والله انا ماني سامع اسف.
أنا بسمع.
تكلفة الضخ في الأردن عالية كثير بخصوص الطاقة، فمن ناحية كاليفورنيا هل في دروس كيف ممكن نوفر هذه الطاقة؟
Pump stations. تفضل.
الوضع المائي بالأردن.
تعرف نفسك مين اللي بيحكي؟
محمد فارس، مهندس محمد فارس، مستشار تحديث مياه.
مهندس محمد خالد. فارس.
أدناك تبي يا زلمة.
والله مسكرات. نعم انفلونزا ماكله هوا الامور.
الوضع المائي في الأردن أسوأ بكثير من اللي شفناه الآن في كاليفورنيا. هل تتوقع إنه الديسالينيشن أو المشروع تبع ريد سي حيكون حل نهائي لمشكلة المياه في الأردن؟ وخصوصا إنه إحنا برضه الخليج العربي خليج طيب. خليج العقبة. مش خليج العقبة، عفوا خليج العقبة خليج ضيق جدا، يعني حتى إذا ندخل إكزام للسعودية وتحلية المياه في الخليج، الآن في عنده مشكلة في الخليج العربي. بعد أكثر من 30 سنة من التحلية أو 40 سنة من تحلية المياه في الخليج العربي،
طبعا سوى.
صفى خليج ملوث تماما تماما. حتصل خلال سنوات قليلة فقط إنه ما يقدروا يعملوا أي تحلية في الخليج العربي. فشو المستقبل تاع خليج العقبة؟ وهل فعلا إنه هذا مستقبل الأردن؟ حيكون خليج العقبة وتحلية المياه من البحر؟
شو رايك ناخذ جوله ثانيه؟ خلينا بلاش كثره الورقه، لانه عندي انا 9 اشخاص سالوا وبعض الاسئله جروبس اوف كويستشنز. فنبلش اول شيء. تفضل دكتور. تفضل.
اول شيء بدي اشكر الدكتور سعد على هاي المحاضره القيمه والمداخلات الطيبه والاسئله. بس قبل ما نبدا وخلي الدكتور سعد يتبحر في الاجابات، لانه كل سؤال سالتوه زن ايشيو بده محاضره لحاله. في نقطتين، النقطه الاولانيه انه دائما ليس المسؤول بيعلم من السائل. كل اللي سالتوه انتم بتتحسسوا كمهندسين وكناس عايشين بالقطاع المياه ومهتمين وبتسمعوا بالاردن بشكل عام، بتعرفوا شو المشاكل وين الحلول. النقطة الثانية اللي أنا بشوفها إنه ليس من العدل المقارنة بين الأردن وأمريكا أو كاليفورنيا في ظل الإدارة وأساليب الإدارة والتمويل. الساينس نفسه، العلم نفسه بتطبق هون وهون، بس بتحكي عن الإدارة والتمويل والنتاجات والفاعلية. أعتقد إنه يعني زي ما بتقارن شيء بشيء ثاني، ما فيها اي وجه مقارنه الا من خلال الدروس اللي تفضلتوا فيها، الدروس المستفاده في هذا المجال. بترك المجال دكتور سعد بس مشان.
تفضل. نبلش بالسؤال الاول. المهندس الحموري بيسال اذا
جمعهم كلهم.
لا، راح اختار سؤال انا من كل شخص. اذا كان في هناك مشاريع مشابهه لقناه البحر الميت في كاليفورنيا، what are the process and the solutions there?
We have a similar project من حيث المبدأ كconcept هو an open aqueduct by gravity moving water من شمال كاليفورنيا لجنوب كاليفورنيا. سعتها 10,000 cubic feet per second، وبتوصل drinking water مياه شرب لجنوب كاليفورنيا. فالconcept of an aqueduct could be applied, and I think that's the concept, using pipes and ناقل instead of open channel. They use pipes, elevated pipes, correct?
Yes. مشروع النقل الوطني هسه شغالين عليه.
هو pipes in California. It's an open channel. It's open to the atmosphere, easy to construct, cheaper, and you control the slope instead of pipes. And the capacity could be controlled also with pipes. Lessons learned: water can be moved, but the problem is the losses due to evaporation. Also, the required power to pump that water over high elevations. In Jordan, I remember when I studied or read about the ناقل الوطني، كان مفروض انه يوصل البحر الميت وينزل 300 متر ويحرك توربينز ويولد طاقة تستخدم في ضخ المي. نفس الكونسبت في كاليفورنيا. The same idea. But instead of using pipes, they use open channel, which is easier to construct, cheaper, and under more control. All you need is precast concrete, and then you slap it together, seal the joints, you're done.
Okay. زميل مهندس محمد بيسأل عن كاليفورنيا اكوادكتس.
Which is
اوكي. زميل مهندس عثمان مشاك بيسأل عن الويست ووتر ريوز والافشنسي تاعها في كاليفورنيا. what are the suggested.
The wastewater use in Jordan or production is a small amount from, if you notice, about 1,700 acre feet per year, which is very tiny, small amount in California. Major cities right now, they use recycled water. For example, the city of Los Angeles, Denver, Colorado, they recycle their water 3 times before they discharge it. So they use the same amount of water 3 times. Recycle, use, recycle, use, recycle, use, recycle, dump. It's efficient, especially if you have an explosion in the population like an issue in Jordan. Recycling could be effective if the right technology, the cost is reduced or managed through renewable energy sources to produce that recycled water. So the feasibility of it is proven in major cities, so it works.
زميل المهندس عمر الزعبي يسأل عن المانجمنت اند كنترول بروسيس للسبلاي والديماند وتداخل الصلاحيات في الأردن وأثرها على.
زي ما حكيت الجفرمنت in Jordan is centralized, comes from وزارة المياه لسلطة وادي الأردن and then لشركات المياه. هذا الستراكشر the way I understand it. In California is the opposite. We have the state of California has the Department of Water Resources responsible for the technical and management part. The State Water Control Board, responsible for the legal action. If someone stole water from the state of California, the California Control Board goes after them by legal means. The Department of Water Resources do the balances and the engineering and the technical work and the construction. This helps in a way that legal issues are separate from technical issues or engineering issues. There, the level of governance goes from the city, county, and the state. The city makes the decision in local planning. Remember the cow flying, what you do at the local level impacts the state. The state has to adhere to the city ordinance. The state cannot change a city ordinance because the city ordinance are made through a city council that's elected by the city residents.
اوكي. زميل محمد البطاينة، مهندس محمد البطاينة سأل سؤال عجبني واللي بيهمنا بالأردن. fundraising tips lessons how to get international fundraising للأردن. هاي شغلتنا.
ضرائب.
Do you remember? Through my presentation, I listed two things. Through taxation, through bonds. Increase taxes on gas, and I know if I said increase سعر البنزين هون 50 واحد بهجم علي هسه. بس they increase the tax on transportation، يعني كل ما تعبي gallon gas باخذوا مثلا 8 cents، 5 قروش أو 8 قروش.
احنا باخذ أكثر من نصه.
56 قرش على
شو أسوي لكم إذا أنا باخذ 8 سنت وبحل المشكلة؟ 60 قرش مش حلينا، منين أجيب لكم تبس؟ لا بس أنت فكر فيها.
8 سنت بالضريبة.
مع 10 سنت من 40 مليون تفرق عن 50 سنت من 10 مليون.
10 مليون طفرانين.
ما هو هاي that's what the state هناك use. They increase taxes by vote. They cannot increase the taxes without the vote of the citizens of the state. They have they put issues on the ballot. مثلا بيوم الانتخابات في واحدة منهم بدنا نسوي واتر باند بقيمة 10 بليون. المواطنين بيصوتوا عليها تاعون الستيت. إذا نجحت بصيروا find a way to collect that $10 billion from real estate tax من ضريبة الدخل real estate. I mean لا عقارات، أيوة عقارات، أو من خلال income tax أو من خلال sales tax ضريبة مبيعات. لما المواطنين يوافقوا على هاي الباند بصيروا يجمعوا المصاري إلها.
احنا ما عندنا هذا الشيء، احنا في ناس بتفكر عنه. احنا مرتاحين
سيدي الزميلة مهندسة رانيا الزعبي سألت مجموعة من الأسئلة عن
50 سؤال سألت.
الديسلينيشن والموديل انرجي فيزيبل سوليوشنز للتصحر والحلول المقترحة للبراكش ووترز.
Pick a question. اختاري سؤال.
التصحر أنا بختار.
لبراين. اوكي. energy. يا سيدنا العزيزة California uses reservoirs هذول الدامز. They drop the water from those dams into a pump station or a turbines to generate power. They use this power that they generate to pump water, move water, and treat water. So basically, it's a recycled system. And they take some of that water they used already, they pump it back up, and they send it back. They keep a continuous process to generate power, sustainable power. بالنسبة للبراين or الconcentrate من الديسال, that's a problem worldwide. There is no one solution that can address that. Whether in Jordan or in California, it's always a problem. بتسوي ملح بتبيع ملح، هذا ما بحل المشكلة. بدك a strategic plan to get rid of that salt somehow without causing any environmental adverse conditions.
السؤال اللي بعده مهندس بسام درويش سأل عن تكلفة الضخ وما هي الدروس المستفادة في كاليفورنيا اللي ممكن نستفيد منها بالأردن.
Sustainable energy production. That's your best bet. Solar, wind, hydro. That's the way to reduce the cost of pumping. Also, in most of our studies to assess the efficiency of systems, we looked at the hydraulic efficiency. We never considered the power efficiency. So now the approach is to look at it from two perspectives: power efficiency and hydraulic efficiency. So if I design a system, if it's inefficient from a power perspective, the system is not successful. So now both things, hydraulic and power efficiency. Now my system calibration process require hydraulics, which is the exact science of engineering, plus the general power generation, when, how much, what type of power I should use.
اوكي، زميل مهندس محمد فارس، هل تتوقع ان الديسالينيشن او الريد سي كانال از سوتابل سوليوشن للاردن؟
يا سيدنا العزيز، الاردن محتاجه كل قطره مي بغض النظر جاي من ديسالينيشن، جاي من ريسايكلينج، المهم increase the supply. عندنا مشكله بالسبلاي بالاردن. California model of managing water resources: increase the supply, efficiency in delivery, efficiency in use, protect human life, protect the environment, and basically provide clean water. احنا هنا the best thing we could do is to, أو أحسن شيء بنسويه increase the supply. We can't control rain, but we can control desalination, correct? نجيب مي من محل لمحل. فالشغلة بتصير إنه desalination is one of the solution. Remember the strategy list I provided you with? Pick one of those strategies. Desalination is one of kind of a block in a big wall. بتحط هاي البلوك بتساعدك ترتفع شوي، بتحط another block بتساعدك شوي. مثلا desalination, wastewater recycling, groundwater treatment and pumping. All of these could fix and help you increase your supply. Without increasing the supply, you have problems. Especially, we are an unstable political region. So population growth could increase by tenfold in a decision.
الله يعطيك العافية. الآن أنا بقترح نأخذ 3 more questions لأنه معنا 5 minutes. نبلش بزميلنا المهندس رفع ايده. خلاص؟ تفضل زميل. الاسم الكريم؟ نزار.
سؤالي هل يعني ولاية كاليفورنيا عندها تكنولوجيا جديدة تمتص على امتصاص الطاقة من الفلات، وإذا استحدثت كيف يكون مبدأها أو دقيقة كيف تكون طاقة الفلات؟
الفلد؟
جاوب مباشرة.
المشكلة بالفلد you can't predict the direction of the flood, and the state of California values the human life. Most of their projects, the risk in their projects is the loss of one human life. Beyond that, the project will fail, will not be approved. So running after floods to generate power, this is high risk. The state will not take it. They will not invest in this kind of technology that will put a human life at risk. But
okay, another question. تفضل زميل.
Less than 15%, between 10 to 15%, 10 to 15%, depending on the region, whether it's. Go ahead.
تفضل مهندس سامي. بالعراق، بالسعودية، والهطل السريع بدهاش.
That's your question. That's your answer. تفضل.
يا سيدي، في عندنا، هو الموضوع طويل كمان. في عندنا نقطتين. النقطة الأولانية إنه في عندنا ظاهرة اسمها النينو. هاي النينو عبارة عن تيارات مائية بالمحيط الهادي، مفروض انه بتأثر على المناخ العالمي، وبالتالي هاي من آثارها وتأثر على التغير المناخي اللي حكى عنه الدكتور. وهاي من آثارها انه زيادة الاكستريم ايفنت سواء كانت فلودز او دراوتس بالمناطق، واللي بنلاحظه بمناطقنا هذا الموضوع. الفلود زي ما بحكي دائما، الفلود از نوت يعني لا هو عيب ولا هو حرام، بس هو الشيء الوحيد تخفف آثاره وتديره بحكمة بحيث انه اللوسز بالممتلكات والارواح تكون اخف ما يمكن. لانه كله انا اشتغلت بامريكا، كنت محظوظ ب 1993 ميسيسيبي فلود، كنت اشتغل مع الستيت سيرفي، اليونايتد ستيت ووتر سيرفي، وشفنا الدمج اللي صار والقرارات، بس العملية هناك إدارة وإمكانيات غير مختلفة. بس هو العملية ظاهرة لازم نتنبه لها، ولازم السبب في مشاكلنا انه عدم وجود دراسات هيدرولوجيه وعدم وجود مواصفات او كوده للدراسات الهيدرولوجيه، هذا السبب الاساسي.